Hey guys, in this video we're going to be talking about um, the effects of adding and removing a data point on the mean and the median. So Brandon works at a small petting zoo with 8 animals. He was looking at some data showing the masses of the animals. So he weighed them and he was looking at those data. Each animal had a different mass between 2 and 160 kilograms. The zoo then buys a horse that weighs 900 kilograms as their ninth animal. So there were 8 animals, all between 2 and 160 kilograms. And then they got a horse, which was 900 kilograms. So that's way higher, right? That's a major outlier compared to the rest of the data. So what is that going to do to the mean and the median? Remember that all of these data are different. So the options are both mean and median will increase, but the median will increase by more than the mean. Both the mean and the median will increase, but the mean will increase by more than the median. Both mean and median will decrease, but the median will decrease by more than the mean. Both mean and median will decrease, but the mean will decrease by more than the median. I think we can agree pretty quickly that it's not C or D. Clearly, 900 kilograms is more, so if the mean and the median are going to do anything, it's going to be increased. But which one is going to increase more? Well, let's take a look at what this data set sort of kind of looks like. So it kind of looks, they wouldn't be this evenly spaced out, but for the sake of my illustration, it's fine. 3, 4, 5, 6, 7, 8, and then the ninth animal is like way out here. Okay, so this is a sort of representation of what the data looks like. So what was the median originally? So 1, 2, 3, 4. The median was the average of these two originally. It was the average of the fourth and the fifth because we had 8 data points and half of 8 is 4. But now with 9 data points, half of 9 is 4.5. So the middle number is going to be the fifth. It's going to be the fifth. So there are 4 below it and 4 above it. So the median is now the fifth. So it moved from being the average of the fourth and fifth to being the fifth. So to me, that looks like it didn't move by very much. Now let's talk about the mean. If these were evenly spread out, the mean was also kind of probably in between the fourth and fifth originally. Depends on how evenly spread these were, but we can say approximately maybe there. This data point is such an outlier that it could move this, it could move it significantly this direction. I don't think it's going to take it like all the way over here. It's not going to take it outside the rest of the data, but it's probably going to take it past past the fifth one because it's such a big outlier. So my prediction would be that the mean is going to increase more than the median because this data point, as far as the median is concerned, it doesn't matter where this data point is. It just matters that it's another data point. So it moves the median from being in between 4 and 5 to being 5. That's all that does. The size of this data point doesn't matter. The fact that it's 900 kilograms does not matter to the median, but to the mean, it matters a lot. It matters a lot. It very much skews that data to it skews the mean toward this data point because it's so much bigger. So the answer would be B. The mean is going to increase more. So let's look at this one. So Suzanne owns a small business that employs 5 other people. Suzanne makes $100,000 per year, and the 5 employees make between 440,000 and 50,000 per year. So these are her 5 employees, and this is Suzanne. Suzanne decides to leave the company and keep the other 5 salaries the same. So this is basically the same graph, but without the outlier. What would that do to the mean and the median? Well, again, the median of this original set is going to be in between. There's 6 data points, right? So it's going to be in between these two. It's going to be the average of these two. The median of this data point is just this point here. So it's moved from here to here. That's what the median has done when losing that point. What did the mean do? Well, we don't know where the mean was originally. So if we say that each of these represents 2,000, we could actually figure it out. So just as a thought experiment, let's go ahead and actually put numbers to this mean because we're given enough information to do that. So we have 40 plus 42 plus 44 plus 46 plus 48 plus 100 divided by 6. And so 53.3. So our original mean is all the way out here. It's all the way out here. So I'm going to do this. This is our original mean. Okay, with this outlier, notice this mean is not even in this data set. It's not even in there. It's all the way out here because of this outlier is skewing it so much to one side that the mean is not even it's not anywhere near most of the data. But if we do the same thing without that 100 at the end, divide by 5 instead of 6, then the mean is 44, which makes perfect sense. It's the middle. The mean is here at 44, which is also where the median is because this is a very evenly spread out data set. So this is our new mean. This is our old mean. This is our new mean. Remind us of where our median is. This was our old median, the average of these two. And our new median is at the same place as our new mean. So you can very clearly see which one moved more. And that's kind of a trend. Generally speaking, the mean is going to move more than the median, especially if what you're adding or taking away is an outlier. Then that's definitely going to be true. If it's not an outlier, if I added a point maybe somewhere in the middle of this set or got rid of a point in the middle, it might not change it as much. But adding or getting rid of an outlier is always going to have a way more effect on the mean than it's going to have on the median. Okay, hopefully that helps, and I will see you guys in the next video.